I would now like to talk about solving triangles that are not necessarily 90-degree triangles. First of all, we have the law of sines. The law of sines may be used to solve any type of triangle. In other words, not just 90-degree triangles. The law of sines states a fact about the ratio of sines and angles to sides. Okay, the ratio states that sine of angle A over little a equals, or is proportional to, sine of B over little side B, which is equal to sine of angle C over little side C. We can use any one of these three proportions as equal to any other. What I'm going to tell you is to be careful, because we're going to see situations where multiple triangles are possible based on the given information. Also, make sure that you do not assume that you have a right triangle unless it specifically says that you're given a right triangle or that one of the angles is 90 degrees. What this means is that you can no longer use the definitions of the trig functions, such as sine of theta equals opposite over adjacent, and so forth. And you also can't use that x squared plus y squared equals r squared, because each of those definitions is only good for right triangles. The first thing that I'd like to talk about is I'd like to talk about side angle angle triangles. A side angle angle triangle is basically where you have two angles given and the side that's opposite of one of those. In this particular case, one triangle is forced. In other words, if you have these two angles and then a side opposite one of those angles, there's only one triangle possible from that given information. All right? To watch for these, make sure that you're looking at problems where you have two angles and then this side is opposite one of the ones that you've been given. So in other words, this situation would be okay if I'd given you A is 40, B is 60 degrees, and then also I could use the same idea if I'd been given side B, because side B would be opposite of one of the ones, one of the angles given here. All right, so I recognize this as a side angle angle problem. That's the first step. And then from here, what we're going to do is we're going to use the law of sines. Y'all see that I've not been given the information that it's a right triangle. I have not been given, the information that one of the angles is 90 degrees. So I cannot make that particular assumption. All right, now on here, the first thing that I can do is I can go and say, on this particular situation, use law of sines to find one of the missing sides. Okay, on here, let's say that I want to find side B, little b. I want to choose a ratio that involves the side I don't know, and then everything else involves sides and angles that I do know. So in other words, I want to use this particular ratio. Sine of big B over little b equals, and then you'll see the pair of information that goes together is the angle A and the little a. So I'm going to use sine of big A over little a. When I plug in, I'll only have one thing that is unknown. So in this particular situation, I would do sine of 60 degrees over little b that I don't know, and then sine of 40 degrees over 4. All right, I'd like to solve this equation for b. b is in the denominator on the left-hand side. So what I'll do is I'll multiply both sides by b to get it out of the denominator. Okay, I'll have sine of 60 degrees equals sine of 40 degrees over 4 times b. All right, now I see that I have a fraction in front of b. To get that fraction to the other side, I'll multiply by its reciprocal. And so what I'll have is I'll have b equals sine of 60 degrees, and then to move that other fraction to the other side, I'd multiply by its reciprocal, which is 4 over the sine of 40 degrees. Right? And then finally, to determine b, I'll plug this left-hand expression into my calculator. All right? Doing that, what I'll get in this particular situation, um, this one I will end up getting, I believe, 5.38918541 as the length of side B. All right? Now, I also need to find the measure of side C. Well, to do that, I have to find angle C first. Well, in this case, I've been given two angles, so I can find angle C by using the knowledge that 180 degrees is the total of the angles. So to find angle C, I can say I know I need to take 180 degrees and subtract off the two angles that I've been given. The two angles that I've been given is the 60 degrees and the 40 degrees. If I subtract those, that leaves me with 80 degrees. So angle C equals 80 degrees, and that's an exact measure. Okay. Now I need to find side C, the little c. What I want to do here is I want to use a ratio that involves big C and little c, and then I want to use a ratio of pairs of things that I already have. What I'll do is I'll go back to my original problem and I see that I have the pair capital A and little a. I'm going to use that pair again. It's always safe to use something that you were given to begin with. A lot of times if you make a mistake along the way, if you're using that mistaken information, you'll get a wrong answer in multiple places. Alright, so here we have sine of 80 degrees over little c equals sine, and this was, I'm having to look back and see what we had. This was 40 degrees over 4. Let me double check that. Yes, that's correct. Alright, to solve this for c, I'm going to do something similar to what I did before. I'm going to multiply both sides by c to get it out of the denominator. So I have sine of 80 degrees equals sine of 40 degrees divided by 4, and then that's multiplied by c. To solve for c, I want to multiply both sides by the reciprocal of that fraction that's in front of c. So I'd have sine of 80 degrees and then multiply by the reciprocal, and that would give me 4 over sine of 40 degrees. Alright, type this in the calculator and you will end up with c equals 6.128355545, and that's the length of side C. This concludes this lesson on solving side angle-angle triangles.